live from downtown Obey. Oh, nice.
And then we're gonna put up.
So, you can get out your notes from last day. Marker.
I mean, like.
What are you doing? Do not mark up my pretty TV.
I was thinking it's like a whiteboard.
You can use your finger, but don't use the nail. We don't want to scratch it. If you have very long nails, as I sometimes do, what do you use that pen?
That one maybe? No. That? Oh, that, yeah. Oh god.
Once you enter, please you can't have your cell phone out at any time in the building. Once you are entered, take out your notes and fill in 3 of the blocks. There you go. Yeah, fill in 3 blocks, any 3. Fill in your notes. Rather than have everybody rush up afterwards. Did you just join or you just transferred? Oh, you were good.
That's the one you did.
Congratulations. So you need everything. Have you seen that before? In grade 9, like, what did you do last year? Oh. Okay. We will need you to read a copy of the notes. And this is our notes document. And you'll need a data table. And congratulations, you quizzed today at the end of the class. So we'll see exactly what you know. There's a live stream that on my Google Classroom. And you can see past. And you'll need a text box. For those who are just entering, fill in any 3 blocks. Any 3 blocks. If you have not filled in 3 blocks, now is the time. And then you said another, no, I called, you said another name. Yeah. I cannot hand you. Yes, someone. That's Julie. There. Of course, I'll win. What song did you do last year? You didn't do any science last year? Like biology? In BC science for grade 10, I'm going to start with chemistry. Then we're going to do biology. And then we're going to do physics. So we'll switch through. Oh, okay. So you might find those a little bit easier. You probably have to study a little bit more.
Julie, can you help?
Yes. Excellent. Okay, what else? Keep that handout. This is also in Google Classroom, but this way. Those are all the things. Okay. Do you have a 3-ring binder for notes where you can put things in? Okay. Stop that, Jodo. Positive words only. Positive affirmation.
Why do you just go gray?
Get ready to learn things that you didn't know before. Would be the same sentence, but in a positive way.
No.
Yeah.
Why is this thing auto adjusting my letters?
It's not. You're on. You're on the wrong type of pen. You're on shape recognition pen. You want that pen.
I mean, chip recognition works too.
Yeah. I don't often use it because sometimes you get it wrong. It's really, you can't just erase it. It makes it really hard to correct. ABC? Yeah. I'm going to quickly do attendance while reading line comes done. We already know time look, so do we have Anders?
Still sick.
Still sick. Caden. Esther. Right. Hillary.
Yes.
Jennifer. Jojo. Julian.
Yeah.
Thank you. Liam. Lucas. Matt. Nick. Oliver. Riley. Deanna. Zachary.
Yeah. Zach.
Zach. Oh, do you prefer Zach?
Yes.
Let me edit my class list and Sue's. Just so you know, if you have a preferred name, you can talk to your house planner or advisor. They let people know, and on attendance and everything, they can just update.
Dude, how should we draw board diagrams and board models?
Correctly.
Like easy way, like fast way for you to see.
Well, if you should draw it the way that makes sense. So sometimes, when we're just looking at number of electrons to say we want valence electrons, or maybe we're just filling up a shell to see what charge it's going to be, efficient makes way more sense because you're just adding and subtracting electrons. But if you're looking at structure, like how an atom looks, then you want Bohr.
If you do board,
But
will we lose marks?
depends if what I asked you. Yeah. I mean, I could tell you I want this type of diagram. Also, very quickly, the reason I'm having you do it with the circle and dot is that we're going to do something called Lewis dot diagrams, which are
That's
essentially
only
a simplified Lewis dot, a simplified circle dot. We just get rid of anything that's not a valence electron.
That's pretty easy.
Yeah. Is there anybody that still needs to come up?
Wait,
You nodded. No? What? Can you what?
fill up with water.
I feel like we spent more time on this than it would take you to fill up your water bottle. Just leave your phone in there, pretend you're going to the bathroom, fill up your water bottle, come back. Yeah, there you go. Have this work out. I want you to check it, and then we're going to do something to build on it. Quiz will be at the end of class. It is a 12-mark, 14-minute. Extra time is built into it. So I will leave more time than that, which reminds me, I should probably know how much time. What time does this class end on this alternating schedule day?
How long is the assembly gonna be?
It's 30.
It's like an hour.
Yeah, 8:15 to 9:30. Okay, so I need to keep an eye on the time.
Yo, boys, what's a suspension?
What's That's what happens if you break any of the major rules here at Drummond College School.
It's okay. It's not in solid. It's just kind of like this place. And over time, it'll like form.
Okay, opportunity. Does anybody see any mistakes that they need? If you can get out the note package that I gave you, put it to this. At the very least, you can start getting things down. You know, hopefully you'll pick things up. Yep.
Okay, I've got all of these. Like, the only one I don't know how to do is
Zinc?
suspension and
Yeah. Julie? Hold on one second. That should all be put away. You're not studying now. We are doing work now. But why is math out?
Math is the best.
Math is just a made-up fiction, like Star Wars.
Yes.
Not even good. It's just useful. Okay, go.
The number of neutrons, 37.
Number of neutrons is 37.
Yeah,
Um,
number of protons is 30.
Oh yeah, it is. What they probably did, as I'm willing to bet that they got their mass number from the atomic mass. So one of the things that this is emphasizing is that if you were given the mass number, you have to use that to get the number of neutrons minus the protons from it. If you look up carbon, for example, you will find that its atomic mass is 12.0. So if you did that incorrectly and you didn't use the 14, you'll probably have 6 there for neutrons, and that's what you did. Instead of using the mass number, you used the atomic mass and used it when you shouldn't. You are allowed to use it when you have no other choice, but if you know the atomic mass or you know the number of neutrons, you have to use it in that way. So let's quickly check.
The number of protons is 30.
For
13.
number of protons.
So this is 28.
Oh yeah.
30.
How? I do not have an idea how. If someone did that and they want to confess and tell us why they did that, because I can't even see where they move it over.
So the charge is positive 2.
Oh, that makes total sense. Instead, they couldn't adjust the number of electrons, so they adjusted the number of protons to make it neutral, and then thereby not realized, and they changed the entire element. That person did nuclear reactions and should be dead because the amount of radioactivity that should have been given off would be huge. I'm going to quickly go through now. One of the things that I'm asking for the symbols to remind you as well, put the mass number at top. So if you didn't do that, go through and do that now. Because I want you all to remember the top number here, that's the mass number. If you didn't put the number of protons in the bottom, the atomic number, that's fine. It's not always required, but this should be on top. And we got 57. That's supposed to be a 2, I think that is, but just to make it clear. The bottom, however, here would not be also 52. The bottom here would be the number of protons if you wrote something below, and so that would be 24. 223. Don't need the brackets. It is radioactive. That's all that means. And again, we wouldn't put it below. If we did put one below, it would be 87. But that was correctly placed. And then 744304, good. C1466806, good. 853636, 49036. 63, 29, 29, 34 plus 2, 20. Ooh. They reduced something by 2, but what did they reduce by mistake? They introduced the number of neutrons. And the things that are charged are the protons and the electrons. And so if this is plus 2, you have more protons. So the number of electrons must be 27, 2 less the number of protons. Are you ever allowed to manipulate the number of protons?
No.
No, not in this class. No nuclear radiation in here. We're going to be safe. 4 and 11, 11,55605. 30, we corrected, 28. 79, 35, 35. This, I think, is 44. Again, you might have been using the atomic mass instead of the mass number. So if you did that, double check. It should be -1, so well done. 36. 52, 24, 24, 28, plus 6, and 18. Nicely done. That's 123, 87, 136, plus 1, and 86. Excellent. Okay. Now, does anybody know why, from last year, why I printed that table twice? I don't know either. I think it's a mistake. Moving on to the next page. However, you can use that extra table for practice, because now you have all the answers. And so for your quiz next week, you can see what you're going to do. Yeah. I just announce them one at a time, and then slowly students discover the pattern. You have a quiz once a week, roughly. Unless we have a lab or something, then we go. Just to check what you know, give you a chance for feedback so you do better on a test. My policy for things like quizzes, So we're going to do some quizzes. So I'll get some marks. You're going to have both a traditional and a competency mark. You'll notice on your quiz today, so this gives me a chance to talk about it, that beside every question it will say CALM, CR, I think, no, CA, or LAB. And that's critical analysis, laboratory and research skills, and communications. And that means I've divided up proficiencies. They're also worth a mark, so I can do both. And then you hand it in, it goes in. At the moment it goes in, it is summative. And then you do another quiz, and then eventually you write a test. If you do better on the test, all of those quizzes become formative. They don't count for marks because you improved. The purpose of the quiz is to give you feedback so you can make a mistake and then get the feedback and then improve later. If you improve, no big deal. They become formative. They're not worth anything. It's the test that worth something. If you do worse on the test, then why would I keep them formative? I'd keep them summative because they're helping you, and at one time you did meet the objective, so that's going to help you. So they are summative at first because it's the only mark I have, and if someone asks me like, how are they doing? I'd be like, oh, well, this is what they got. But nothing actually gets registered. Do you know what mark appears on your transcript when you like leave here, and if somebody ever saw your grade 10 mark, what do they see in your transcript? A little bit more than that. Have you ever heard like this is going on your permanent record? Yes, there's lies. There's no such thing as a permanent record. The only permanent record is the percentage. They don't even give a letter grade. You got this percent. No competencies, no term marks, no nothing. So really the only mark that matters is the one in June. Everything else is, in a way, everything's formative until the end of the year, and we put it all together and see where you should be. So if you're having problems with something, come see me tutorial. It's not going to be a big deal, but I want you to have practice every week looking at it and going, how do I solve these problems? So you're keeping up with the notes and not falling behind and have a chance to get feedback. Okay, nitrogen. What I want you to do up here is give me the simplified or efficient Bohr model with only the protons and electrons. So how many protons does nitrogen have? Pull it through the table. And hands, you've already answered the question, I'm pretty sure. How many protons? No, don't say it out loud. Yes. Excellent. 7 protons. And then, therefore, if these are all atoms, how many electrons would it have?
7.
Ready? I can't call it. Yes. 7. How many fit in the first shell? Everybody. 2. So it would be 2, 5.
Do we not put the neutrons?
Nope, I said no neutrons. Jimmy Neutron has gone away. How many valence electrons does this particular model have? You called out. You already know. I want someone else. Oh, right. I have my app.
I need more points.
You don't get points when you put up your hand. I just call you because we're not recording anything at that point. So the only way you get points is if I go random.
No reason for me to answer
And then it
that.
says, Caden.
I don't know.
Oh, excellent, excellent. It's either 2 or 5. Is it the outside one or the inside one? Excellent. See, you did know. So below where it says valence electrons, I want you to just write 5. So you write the number of valence electrons down below. I want you to do this for everything up here. Don't touch that down. Everything up here.
Oh, I wasn't supposed to
Go
do
gadget machine.
down yet.
What?
I was supposed to do this yet.
No.
Oh, well.
How dare you?
I'm sorry.
You're also going to have to draw in there. Can you erase that?
What?
Yeah.
I thought I just had to.
No. Never work ahead.
I might be.
Yeah.
Oh well. I'll just do
Yeah.
it somewhere else.
Don't worry. I'm going to just lower your competency now.
No.
Self-immersion.
Which one? What you wrote? Yeah. 7p2, 2 electrons, inner shell, 5 electrons, ocean. Do you get it? Like in between 2 and 5, is that just a comma? Yep.
And then I'm going to go. Are you good to start? Like, any questions?
Oh no.
Questions? No, because you already done that. Yeah. So the simplified, so 7 protons, 2 5. So the Bohr model just is a straight line like that. And then below that, the number of valence electrons.
Oh, I have to put the number. Okay. Let's put a minus next to it, like the number.
What number?
Electron. Like a little minus.
I didn't put any E's up there.
Okay.
Yeah. You can leave off the E in the simple Bohr models.
Okay.
And then what do you write down below? Yeah. It's asking for the valence electron. Just what is the valence? Does that make sense to you? How do you know that nitrogen has 7 protons? That's the atomic number, so that's where you get the protons. And then how many electrons fit in the protons? So you put that there. You have 7 electrons total because the atoms are the same. And then you have 5 more total. How many electrons fit in this second? You're about to say, yeah, 8. So if this, let's say you had like 12 electrons, you go 2, 8, and then 4, all the leftovers, you don't put that. And then you just take the last number, put it down there, because that's the number. Is that enough to get started? Excellent. Okay, you got a periodic table. Have you heard of protons, neutrons, and electrons before? Excellent. So the number up top here is called the atomic number. And that's the number of protons. Have you done the Bohr model at all? So the Bohr model, as when you draw and you put the, this is really handy, it's there. So this is for fluorine. So if we look at fluorine, it is 9 protons. And then the number of electrons on the outside is the same as the number of protons, but they go in rings. So the first ring only fits 2 at most, and the second ring only fits 8. Have you done that before? 2, 8, 8. Okay. And then the third ring fits 8 as well. So if you have, in this case, 9, and you put 2, it's filled up. 2. And then you would take minus 9 is 7, and then you put, I don't know why it says 8. Then you put 7 in the next one, 2 plus 7 is 9, and then you match, and then that's the correct one. So that is very close to what I was asking before. So that's what I've done here, 7 protons, 2, 5. Yes? At that point, you just stop looking at it once you got the number of protons. How many electrons do you have?
The
You got
electrons.
9, and how many fit
It's
in
the
the
same
first?
number as protons, so 8. And this is 8 electrons.
2.
Wait, so that was just 2 in the first shell.
Pardon?
The remaining in the second shell.
That's all that fit in the first shell. It's just a law of the
The
universe.
Bohr model,
To explain why, I have
it's
to
like
explain
2
quantum
to
chemistry,
here.
which we don't cover.
8 can fit in it. It's 2, 8,
It's
8, 16.
electrons
But you don't
are
need the
waves,
other ones.
and
You
when
only
they
need
form
this
a
one.
wave,
So
it
it's
forms
just like
a
I'm
shape
writing the
beyond the
transmitter
Bohr model,
right
and that
now,
shape
how
only
many-
fits so many. And when it literally, you can imagine that maybe a bigger balloon, it fits more stuff, but it's small. So the first one just doesn't fit more than 2.
So most of the
The
time it's
next
always
one
2
will
first.
fit.
Yeah, it's always 2 first. Only if it's like, if you're doing
Now
like
the next
hydrogen,
one's
there's
not 8
only 1.
because you had 9 in total. You put in 2. Yeah. And then, and then do that for all of them. So carbon, 6, proton. And down below,
The number of
because that
valence
last was 7,
electrons
so
from
you
5,
put
6.
7. You got it? Are you good? So
Right,
this
it's
one.
one.
So
Are you good? All right, you got it all going? Got it now
Yeah,
going?
well, this one's trying to call. This is no.
Oh, you're in protons first. How are you doing?
No.
Hydrogen was too sweet.
Anyway. Oh. Are you good?
Oh, you're out of sports.
Sure, no, how you doing?
I've heard of the girl.
Ooh, cool.
There's
We
two
did
in
one
there.
together with, right?
Yeah, we're going to.
Yeah, that was really cool. Okay. Now, let's write down an example I put up there.
Yeah.
Just so you can see it.
You know,
Cut-
is
cut-
that Asian
Yep.
girl?
And yeah, no,
Like
that's good.
the crutches. Okay, maybe.
Don't do the second one yet.
Uh,
No,
Okay.
no, you can just kind of say, what would you like me to help you with?
Their irony is so short.
So I wanted you to fill up the whole top of that page. All of
Wait, I feel like
It's
happiness
like
is like
it's
true
spelled like
communism
this.
turns into just anarchy. Because like
I spelled it like
true
this.
communism is like they have government, everyone's equal, and then the government goes away as it's not needed, which is no government. But then that's anarchy.
What's no government?
Anarchism, right?
Kind of. There's actually forms of anarchy that do have government.
It's just like really weak.
But they're collective based. So like everybody gets together. There's a lot of committees.
Wait, so
And then it bleeds into other forms of government. Because as soon as you start organizing, it does get away from anarchism. But there are some versions. But yeah,
in itself can't ever exist fully.
nothing. You could say nothing could ever exist fully. Because all of them are just ideas we made up. They're not reflections of the real world in any non-subjective sense.
You're telling me that hydrogen doesn't exist.
No, I'm saying things like capitalism and democracy and true love don't exist. But we think they do, so they do. But if we stop thinking, they'd stop.
I'm more about the definition of anarchy doesn't actually possibly exist. The laws have to survive.
I don't know. There are groups that have shown that they have worked successfully with an anarchist system. People are just cooperating, but they don't get together to form executive decisions. One of the humans' main functions. Why do you have your math out?
Just dumb.
Give me your math.
No.
No math for you.
No.
No. I'm going to. I'm going to put it on the fire barrel.
Oh, no.
Or it might get burned.
Okay.
Hmm.
What do I do when I'm done?
You could help others. Find someone who doesn't have it complete. So, Julian, I want you to walk around, find someone whose table isn't complete, and help them. Oh, there's one.
I don't think so. Luke got mad at me.
Oh, you can't read in class. I give you back away. That's like as bad as it is, right? Yeah, it is. Reading, getting knowledge from words, there's something deeply suspicious about that. Okay.
Good job.
1, 2, 3, 4, 5, 6, 7.
No, one. Is it the last one? Surveillance. I almost forgot to do it.
Or what if the monsters have or one monster is not
I'll be annoyed at other people are high.
Ooh.
why is it passionate?
Bro, I feel like George still
Move.
I've got one question.
Can I change my monster? It's kind of ugly. What was the point of that?
my group 15.
My dorm monster was 15. Let's go.
Okay,
Oh.
okay.
Do I get points?
Jojo, you're not 7. You're actually 16. Everybody else, everybody see their group number? You're in groups of 1. Your group number is the atomic number of the atom I would like you to come up and draw. And since I already drawed nitrogen, I'm going to say, Jojo, instead of being 7, you're going to be 16.
Mr. Newfield,
Yeah?
just pull up the thing again, I forgot my number.
What?
Same.
15.
Julie.
Everybody stare at their number and write it down on their piece of paper right now.
Thank you.
1, 2. You do not draw on this with a whiteboard marker. Put that away. Drop the whiteboard marker. Back away slowly.
Silicon.
You may come up here and write with your finger. Please draw the board model as you have down there. Let's take a look at them. Where'd the pen go? Because I had that when I was walking around.
I'm holding it.
Oh, excellent. Someone had it.
What just happened? 14, 15. We need an eraser. Where's the eraser?
It's a different setting on here.
This one?
This one?
This one? The ones
Oh,
I got.
he's
Don't draw.
going to erase it.
I kind of like after that.
Yeah, think.
Oh.
We're going green the entire way.
Yay.
Q3 is just the electron, but it adds up to 6, which is the same there. And the first one is always 2. So you can't go one. The second one can only go up to 8. And so we do here and Q8. The rest that's left. So there you go. So that's or bond. Oh, no, don't worry about the charge. You're just doing the electron. Just go to charge. So 11.
Oh, you can. I think you can draw at the same time.
You're close though. You can only fit 8 in there. So it's 2, 8, and then what's left over? Yeah. There you go.
Mr. Gerard.
And then that's the valence electron. So that's just the one with the outermost electron.
How long will the assembly be today?
I have no idea.
Can we get like an estimation?
It's down for.
It's gonna be over whenever I start.
Yeah, I mean,
I'm trying to make over
Yeah.
the
Yeah, it's gonna be over. Yeah,
on like the
it
assembly.
Wait, all
is
erase two.
said to be
Okay,
from
go ahead.
9:45 to 10:30.
There's no way.
Over under
Yeah.
hour. We'll do over under hour.
I'm going over.
Okay.
Over.
I'm going over.
Okay, no betting on the assembly.
We're not betting.
We're not
just
betting
It's
anything.
just like friendly.
Fun.
It's a friendly game.
Yeah, I got one.
You say aluminum or aluminum?
Yeah.
You say aluminum.
Wait, does the timer start when you sit down?
Yeah.
It starts with the same as
When they say please stand.
But they don't say please stand.
They will. When we can start when somebody's doing the thing so
Who's number 5?
I don't know.
Number 5? That's you? See? Tiny my number. Ha ha. Wow. Yes.
Did someone do Melon?
Sure. Okay.
Julian, someone
Say
did
yes.
Melon. What?
And now you owe me a favor.
Mr. Neufeld, somebody
Yes.
did Julian TG's like element, but like by mistake, I guess.
Well,
This
this
was
is
like
like,
phosphorus.
well, Julian GG,
Yes.
do potassium.
Okay. It's number 19.
Yeah. We only went up
Do you know how to do the Nick
to
shell?
16.
Do you know how to do 4 shells? No. You got this.
You got this, Julian. You got
Can I just do the same? Just
Do the same thing. 288.
Okay.
Yeah, I know.
Wait, it's...
What are you doing, man? Don't touch it with your pickup. Don't touch it with your pickup.
What is that?
That's all you. Ooh. Good job.
Okay. I'll do the last one. So calcium is 20, and it goes 2, 8, 8, 2, and we got 2 valence electrons. Highlighter. Now this is where I say, let's notice things, shall we? What is the number of valence electrons of hydrogen? Lithium.
1.
Sodium.
1.
1. So
They're in groups.
they're in groups.
Okay.
Weirdly, all of these form what kind of ion? Do we know? It's on your periodic table.
-1.
-1 or plus one? Plus one.
Awful.
There's a rule. Ions result from atoms oh, no, hold it. I just want to phrase it correctly because I'm going to shorten it. From atoms completing or emptying their valence shell in the laziest way. And no, you can't have your math. Laziest way is a fancy way of saying lowest energy. So it wants to get to the lowest energy, and it turns out having a full shell or a completely empty shell are both fairly stable, but you want to get there in the most efficient way. So if you're hydrogen, not hydrogen, forget hydrogen, that's a stupid example. If you're lithium, would it be easier to gain 7 or lose 1? Lose 1. So it loses 1, and then lithium, and if you look at your periodic table, it's true. If it forms an ion, the most likely ion is +1. What would its electronic structure, the electrons, look like?
2.
It would just be 2, and there'd be nothing in the valence shell. The number of electrons in the valence shell would be 0. Riley, question?
Are we writing what's in purple?
Yeah. And now that I said that, I'm like, it's kind of messy. Should I text recognize it? I don't really want to text recognize it because I'm pretty sure it's going to come up badly. Ooh. And just don't forget that laziest means lowest energy. Okay. Yep. And now I'm going to belabor the point. Also, I said let's not consider hydrogen. That's a stupid example. Those of you who are done, why is it a stupid example? Your hand was up first.
Because it could either lose 1 electron or gain 1 electron to get a full or empty shell.
It could do both. And if you look at your colored periodic table, where do they put hydrogen? Both sides. Because it can be -1. This -1 is known as the hydride ion. It's often +1. It seems to want to give it up more often than others. But you know, it's bi. It can do both. Twice the chance of a date on a Saturday night. But then lithium, gaining 7 is kind of hard. So it doesn't want to do that. Julian?
Like, what about for the fourth group? Is it +4 -1?
I was just about to ask, what other element would have twice the chance of a date on a Saturday night? So which one? So the fourth group, so carbon could be, it could gain 4 or it could lose 4. So it tends to, it can do both. Now silicon is on the metal-non-metal line. It's got such a dense core of electrons. It can do both, but it's more likely-ish to lose them. And then if you went below silicon, that one is actually more likely-ish, even more likely-ish to lose them. So there are trends that will happen based on other factors, but roughly speaking, it can go either way. So,
What does the red say at the top?
what does what?
The red say at the top.
Lowest energy. I will try to recognize that. I don't think that'll work at all. It worked. It put a 9 in front, which is weird. But on the other hand, that arrow was weird. So we'll just pretend that's the right arrow. Here we go, lowest energy. And we can see now, valence electrons are the same for every column. This is why we call them families. They like to do the same things. All of these want to give up 2 electrons, so they all form +2 ions, which means their chemistry is extremely similar. And so like families, like some families, they kind of look alike.
Why do they slap helium all the way on the other side?
Now, helium slapped on the other side because how many electrons fit in the first shell? 2. How many does it have? Does it have to give up any or add any? No, it's just happy. It's sitting pretty. How many does neon have? 8. So they're not the same, but they are all full. So do they have to do anything? No. This is why we call them noble gases. If we were to name them today, we'd probably call them, the 1% or something. They have everything they want, so they don't need to do any work. They just sit there being themselves. There is the possibility of getting bonding. Researchers at the University of British Columbia actually won a Nobel Prize because I believe it was krypton. They were able to force it to bond. The atom was so big with electrons, the outer electrons, they were able to get them to perform some bonding. But it's actually really difficult to do that. They are so stable, they don't want to do anything. They're just a gas. You put helium in your lungs, and that's why you get a high squeaky voice, because it's very light. It's only 2 protons, 2 electrons, and so the really light, less dense air makes your vibrations go faster in it, just like a lighter string that strums faster and your voice goes high. But if you put something heavy in, your voice would go deeper. And it would be very stable. However, it is deadly to put in something like argon, and yet fine for helium, unless you're not drinking or breathing straight helium for hours on end. But if you just, take it a bit, it's fine. Why would it be dangerous, even though this is completely unreactive? It's not going to do anything bad to you. Yeah?
Heavier.
It's heavier. And what would be the problem with having heavy gas in your lungs? It sinks to the bottom. And then you can't get it out easily, and now you're not breathing oxygen. And so that's not good. And I say that because there's now a possibility of buying that online.
What?
Yeah, you can now buy all sorts of stuff online. Maybe it's just me. Okay, what I would like you to do is not write the most. I wrote that twice. So let's get rid of that. Not charge, structure for each ion, and the most likely charge of each ion below. So similar to this, I'm going to do nitrogen. Nitrogen's element number 5. So 5 is nitrogen. I'm going to put the number there to remind me. And then we've got 5 protons. We have 2, and then 3. But if it becomes an ion, is it going to get rid of 3 or add 5? Get rid of 3. So we'll do that. Now, what charge is it? Plus 3. So I'm going to write that below. And we're going to do that for all of them.
Oh,
Yes. Go, Julian.
I do more balls. Can I just do like a few?
No, all of them. Also, you've been putting. Hold up, what time is it? It should be
Do
7.
attendance at the start.
Go, go, go. Pardon?
Did you do attendance at the start?
Yep. Why?
I heard you say attendance.
Yeah. Oh, yeah.
No, you're crazy.
Yeah, that's one.
No, he's right.
No, that's
He's right.
No, it's below.
Wait, what is the purpose of the 3 star?
All right, it's 5 valence, not 5. 2, 3, 4, 5. What I'm gonna do is I'm gonna erase it, and then I'll pretend it never happened. And because there's no marks, nobody will ever know.
You know.
Did
You don't know?
Button?
There's no evidence.
And if I press that
You're
button,
students. Nobody will believe you as witnesses.
Every single one of us says so.
Children
There's
lie.
video evidence.
There is the live stream. I did not account for that. Yes, there is the live stream. So I gave you boron as an example, and I called it nitrogen as an exercise to you. That was a teaching moment. I did it on purpose.
Whatever you say.
Yes.
so you just do it with the iron now. Really? Do we have to add like the thing on the side?
Everything that I did.
Like this thingy?
What? No, just the charge is just written below.
Okay.
Yeah. You just wrote it really big.
Yeah, because I thought that's all you had to do.
Yes, sir.
So what do we need to do now?
So, we went here. So you're redoing these in a way, but you're making a decision. You know the second one only goes to 8. So if you're here, would you get rid of 3 or add 5 to get to 8? Which is the laziest way to do it? So you get rid of 3, and then since you got it's 5 positive and 2 negative, it would be plus 3. For this one, would you get rid of 2 or add 6? Shh. Get rid of 2, so it'd be 4 protons and 2, and then this would be plus 2. Now, if I went over here, would you add 1 or get rid of 7? Get rid of, really? Add 1, that would be way easier. And if you add 1, then you'd have 2, 8, and the charge would be minus 1 because you added an electron, which is negative. Does that make sense? Does that make sense? Excellent. Yes, student.
Don't carbon, boron, and aluminum rarely form ions?
Do the thing.
But like it almost never happens.
Because this is, you will get questions that say, if they were to form an ion, what ion would they form? And they can all form ions using this rule.
And carbon could either lose 4.
Yeah. Shh. I'm going to let people make their own decisions. Riley?
What do we do with the black boxes?
You ignore them. I will show you later on why they're there. They're there for technical reasons.
And then you forgot to get rid of them.
Yeah, that's pretty much the technical reason.
Yes.
You understand, John? So, I get like the charge set here. What's the middle part? It's the same thing you did here with the electrons. It's just that you want to make it complete. So it's either you want to make it so it has a full valence shell like this. For example, let's do sodium. The crap one is this is gone and that's gone. You want to make it because each one has a charge on the periodic table. So you find a charge and it tells you like what to do with this. You get it?
Let's go with boron. Right here. You know why you have 5 protons? And do you know why you have 2, 3 right there?
Because
It makes 5, and only 2 fit in the first of the 3. Now we have to ask for that shell. This is neutrons now. But if it's an ion, it has to lose or gain electrons. Is it easier to lose 3 or gain 5 to get to 8? Lose 3. So you rewrite it here as 5 with the 2, and you lost the 3. If you have 5 protons and 2 electrons, what's the charge? What's the charge? Because protons are positive and electrons are negative. Yeah. And a very quick way to do the charge would be protons minus electrons, so 5 minus 2. And for all of those, you can do that. Try the next one.
so basically just wanted to get into a full valence
Just-
shell. I have 2 or 8.
Take, because that was boron, right?
But how do I decide which one to get rid of?
Always the outermost ones. You're looking at the outermost one, whether you add or remove, because the inner ones are always full.
And the charge tells you like how many you want to remove or how many you want to add.
Well, you don't even need that.
Yes.
Because this gives it away, yes. But like you notice in here, it has multiple charges. And that is because, here, since you are bored,
I don't know
let's-
why, but like I know.
I can show you why.
They just tell you which one.
Yeah, but I can show you why. Let's take something like,
So would this be 2 here? Sure.
yep,
So it's just this and 2 every time.
yeah. And then what's 6 minus 2? So it's plus 4.
It's different for some of these. These want to make 8.
Yeah. So this one would either get rid of 7 or add a 1.
This one is.
This one right here. Sure.
Wait, to -7 or.
Yeah, because you have to make the outer one either empty or full. So it'd be easier to add 1 to get it to 8, or minus 7 to get it to 0.
Plus 1 to where?
What's 7 plus 1? And how many fit in the other shell? 8. So if we added 1, we'd get it to 8. And then that would be that would have a charge. Or we could take away all 7 and make it empty. Which would be easier? Rolling 7 things away or adding 1? Adding 1. So then this one would be 9p to 8. Yeah. Now, if you add this up, what does that add up to? What is 9 minus 10? So that's the charge. Will that help you do the rest of it? Okay, I am going to ask you to stop, put it away. I'm going to give out your quiz and explain a few things with it. Get out a pencil, an eraser, a calculator if you wish. And you can, for this test, quiz, use your own periodic table. I am first going to give you the answer sheet. Oh.
Well, they asked me if
It would be really sad, right? I'll take that for a week. Particularly that is true. And there's a ton of students here after practice. You wouldn't expect it to be on a desk in a classroom. So if you could throw it away carefully, like it's a bomb.
Okay.
Yeah.
I guess.
Do you need to cut it? Would you like to cut it? I have a couple of extras. Please take everything off of your desk, except for what I said you needed. Binders in your bag on the floor. Everything should be on the floor except for what you need.
Let's go. It's multiple choice.
Pardon?
It's multiple choice.
Some of it's multiple choice, yeah.
Let's go. Julie, at least get 25%. Yeah. Oh, automatically. Wait, how do I? What is this?
Wait,
Have you never
what's
done
our
a
student ID?
test like this? No, I've never done multiple
Just
choice. They give you
hang
one,
on
and
to it
it's
for a
like,
second.
what is this? A, B, C, D, and you circle it. Just
Just ignore it. You don't write anything on it yet. I'll leave it up so I can explain it.
Can I write my name?
Pardon?
It's like a
What
Ralph Lauren test.
Oh,
Results back.
atoms that have the same number of protons, the same element, but different numbers of neutrons. So they weigh differently. Put that in your bag. Binders in bags, please. This has to go away. You can't have it under your desk. Under your desk is good. Whoops, sorry. Okay.
You can just work on the.
As of now as well that you have everything put away, please spread out. So move further away, spread your desks out if you're crowded together. Someone here could go back one. There you go.
Is this far enough?
Yeah, that's getting good. Yeah, okay, I think we're good. Excellent. Now, what you have now is the multiple choice answer sheet. You only put multiple choice on it. It has more questions on it than are on the quiz. Leave the questions that aren't multiple choice in the quiz blank. I actually use those for the long answer to indicate what proficiency or mark you got. And on it, please write where it says your name, your first and last name. Leave your student ID blank. It is not the same as your Brentwood student ID. I am going to assign you one for the special program that can use that sheet. You can leave your version number blank. And the quiz name, write down something meaningful. Bore, matter, quiz would be fine. And if you can indicate the block, what block is this?
C.
C.
B-O-O-R-E. I think so.
When you fill it in,
Oh, B-O-H-R-E.
you can fill it in pen, but I would highly recommend you don't, because then you can't erase it if you change your mind. So, if you believe, for example, you read the question, and you're like, hey, I think the answer's C, don't do this, don't do that, don't do this, do this. Fill it in. Ideally in pencil. It doesn't matter what kind of pencil. And if you have an erasable pen, that'll work. I can pick up anything. I just want to make sure that you can change your answers if you want. The long answer you're going to write directly on the sheet. Are there any questions? Okay. You may begin as soon as you get it. Please, once you get it, put on your name.
Thank you.
And when you're done, you can get out your binder and continue working on what we were just doing. And go